Today's lesson is on quotient of powers. Pretty similar to yesterday's product of powers. Difference being, quotient of powers is dealing with division. So when you divide powers today, and when you divide powers, they have to have the same base. When they have the same base, today you will subtract the exponent. Just a quick example to show you why this works. You have x to the 7th divided by x to the 3rd. X to the 7th is basically saying that you have 7 x's on top, and the denominator you have 3 x's there. So when you look at this and you actually simplify, you can cancel out some of these x's. So you can cancel out 3 off the top and 3 off the bottom, leaving you with 4 x's. Well, that would give you x to the 4th. Another way to look at this is, since you are dividing and both numbers have the same base of x, you can subtract exponents. So basically, here's your same base of x. Your numerator is 7. 7 take away 3 would give us x to the 4th. So same type of concept that we have there. Today again, you'll have to simplify. Answer should contain only positive exponents. So we'll give an example here. Let's go ahead and start with 2 to the 4th divided by 2 to the negative 3rd. When we do this, first off you need to check, do they have the same base? Yes. The base number in this case is 2. So I'm going to go ahead and move my base out. When they have the same base, you subtract your exponents. So we have 4, the numerator. It is dividing, so we can subtract our exponent. In this case, the bottom is a negative 3. So we're going to subtract a negative 3. When we do this, we have 2, and then the exponent is 4, take away negative 3. When you look at it, 2 negatives right there next to one make a positive. So we have 2 to the 7th power, and then we can go ahead and simplify, giving us 128. Example 2, we'll start out with 2a to the negative 2nd over 4a to the 3rd. Looking at this problem here, I'm going to go ahead and write things out again. So I have 2 over 4. Now I wrote it like that because I'm going to go ahead and take care of my same bases. Well, I have a and a. Those are my same bases. When they have the same base and you divide, you subtract exponents. So in this case, I'll have a to the negative 2, which is your numerator, and it's being divided by, so when you divide the same base, you are going to subtract, and you're going to subtract by what you have down here in the bottom, in this case 3. So this is what your problem looks like. You have 2a to the negative 2nd minus 3 all over 4. When you do your computation here, you would have 2a to the negative 5th all over 4. Now this problem still needs to get simplified here. In order to simplify this, while I look at my fraction here, 2/4 can be reduced. A 2, well, this can go into a 1, and the 4 would go into a 2. So basically now you would have 1a to the negative 5th all over, 2. Still not complete with this problem. Reason why is we have a negative exponent. We need to get rid of that negative exponent. In order to get rid of it, we need to move it to the bottom. And this a to the negative 5th is in the numerator. Slide it down to the bottom to get rid of that negative exponent. And on the top we still have 1. On the bottom you have 2a to the 5th. Example 3, we have 2n to the negative 4th divided by negative 4n to the 4th. So again, I'll go ahead and rewrite my problem here. I have 2 over 4. I'm going to go ahead and write those whole numbers down. And then I have n to the negative 4th already in my numerator. And here's my same bases with my n's. So I need to, with division, same base, you subtract your exponents. So I'm going to subtract by the exponent on the bottom, in this case 4. Here's what my problem would look like. When working through it, I would wind up with 2n to the negative 8th all over 4. I can go ahead and reduce within my problem. 2/4, actually this would be a negative, sorry, forgot to put that negative sign there. Now we can go ahead and reduce within our problem here. This 2 is going to become a 1. The 4 would become a 2. When I rewrite, I have n to the negative eighth all over negative 2. I can put the 1 here up on top, not necessary, but I can put up there. Now I can go ahead and get rid of my negative exponent. When I get rid of that negative exponent, this is what I need to take care of. This is what I need to slide down to get rid of that negative exponent. So on the top I would have 1 over, the denominator would be negative 2 n to the 8th power. Check out example 4. In example 4 we have 2m to the negative second divided by 3m. Same thing here. Going to just rewrite this. We have 2 thirds. We have m to the negative second. When you divide and they have the same base, you subtract the exponent. In this case, the exponent on the bottom, m does have an exponent. It is 1. So we need to subtract by 1. When we subtract by 1, the problem would be 2 over m to the negative third, and this would all be over 3. Now if you look at this, look at those numbers there, 2 and 3. Can't reduce there. However, the problem is still not done just because of the fact that we still have a negative exponent. The one that has the negative exponent is m to the negative third. Get rid of that negative exponent, we slide it down to the denominator, leaving us with 2 on the top over 3m to the third. No negative exponent, answer simplified, looks good. Example 5, 4b divided by b to the fourth. Well, if you look at it, here's our same bases there. The b's are the same base, so when I rewrite this problem I have 4b. Now remember, this top b does have an exponent. It has an exponent of 1. So I'm going to put the 1 there. So 4b to the first is basically what it's saying. Same base, and you divide, you subtract exponents, so we are going to subtract by that denominator exponent of 4. And then this is basically what I'd end up with. So I have 4b to the 1 minus 4. When I do that, I wind up with 4b to the negative third power. Not finished here because of the fact of the negative exponent. And in order to get rid of the negative exponent, let's convert this to a fraction first. Take care of the piece that has the negative exponent. In this case, it would be b. Slide it down to the denominator. Numerator, we still have 4 on top. On the bottom, we have b to the third. Last example, example 6 here. Again, go ahead and take care of our problem. I'm going to go ahead and write out 3/4. We have r up here on top. Remember, r does have an exponent. R has the exponent of 1, so I'm going to go ahead and throw the 1 there. 4 stays down on the bottom. We have the same base of r's, so we need to subtract because we are dividing, and we are going to subtract by the exponent on the bottom. When we subtract, we are subtracting by negative 4 in this case. So 2 negatives that we see make that big positive again, and we wind up with 3r to the 5th over 4. And when we're looking at this problem, we don't have any negative exponents, so our answer would stay the same here. Another way that you can go ahead and solve this problem, I'm just going to point out another way. In example 6, if you didn't like that method, you could have 3r over 4r to the negative fourth. Another thing that you could do is you could tie yesterday's lesson into it right away. You see that r has the negative, so you could actually go ahead and move this to the top right away. When you do that, you have 3r, r to the fourth comes to the top, all over 4. Now if you look at this problem here, these r's on the top, that has an exponent of 1, are really all these numbers are being multiplied up here. So when you multiply and they have the same base, you add those exponents. So these are multiplying up here on the top, so we can add the exponents, which give me 5 over 4. And notice 3r to the 5th over 4 is the same, both techniques. This concludes Quotient of Powers.